Hello everyone. This is Notes for 4C in Unit 5. Notes for 4C in Unit 5. So our first question, we're going to start learning how to work with negative exponents. So the first thing that I'm going to do is I'm going to go to a blank white screen, a whiteboard, and I want to explain a couple of things to you before we get into the lesson. So about a little over a week ago, we learned about exponents. So we learned that 2 to the third equals 2 times 2 times 2, which is 8. So we learned that 2 is the base and that 3 is the exponent. So when you have a positive number, 2, to a positive exponent, 3, it means multiply 2 times itself 3 times. All right, now, what if instead of 2 to the third, what if you have 2 to the negative third? Okay, if you have a positive exponent, it means multiply that number by itself that many times. So 2 is your base, so you're multiplying 2 times itself 3 times. Well, if you have a base of 2, but now an exponent of negative 3, it means divide by 2 3 times. So if you divide, the fraction bar means divide, and you divide by it 3 times. So it means divide by 2 3 times. And it ends up being 1 over 8. Now, what I'd like you to do is I want you to compare the answer that we got on the left, which is 8 over 1, and the answer that we got on the right, which is 1 over 8. And I want you to notice that they are reciprocals. Okay, 1 over 8 and 8 over 1, or I should do it the other way, shouldn't I? Okay, 8 over 1 and 1 over 8 are reciprocals. Reciprocals. Okay? So now let's look at the original problems that we had. So we had 2 to the third, right? So 2 to the third over 1. Okay, now in the green, we had 2 to the negative third. Well, I want you to think about what that equaled. So 2 to the negative third ended up equaling 1 over 2 to the third. So do you notice that you just do the reciprocal? When you do the reciprocal, you end up with the positive exponent because now it's where it's supposed to be. Okay, so when your exponent is positive, it means multiply the base number times itself that many times. When your exponent is negative, it means divide the base number by itself that many times. And the key is that you're just doing the reciprocal. Okay, so now let's go back and let's look at our page here with our original problems. So if you look, if we have x to the negative n, we do the reciprocal. So remember, if it's not a fraction, it's got an invisible 1 underneath it, right? So then it becomes 1 over x to the n. And now the exponent is a positive. If you have 4 to the negative 9 over 1, it becomes 1 over 4 to the positive 9. Okay, now, what if your negative exponent is in the denominator? What if you have 1 over x to the negative n? Well, then it becomes x to the n over 1. So, whichever way that your exponent was, the negative exponent, whether it was in the numerator or the denominator, when you do the reciprocal, the exponent becomes positive. So, if you have 1 over 9 to the negative 11, then you do the reciprocal, 9 to the 11th over 1, and now the 11 is positive. Okay? So now let's look at our first problem. So our first problem is 4 to the negative 5. So remember, that's 4 to the negative 5 over 1. So then it's going to become 1 over 4 to the 5th. And that's what we're going to type in. 1 over 4 to the 5th. So 1 over 4 to the 5th power. Okay, now we have 1 over 8 to the negative 6. So we have 1 over 8 to the negative 6. Okay, it's going to become 8 to the 6th over 1. Okay, now, do we need the 1 in the denominator? We don't. It's just 8 to the 6th. Okay, so everybody, we're going to go type that. 8 to the 6th power. Okay, now we have 6 to the negative 15. So we have 6 to the negative 15 over 1, and it becomes 1 over 6 to the 15. So now we're going to go type that in. 1 over 6 to the 15th. And then we have 1 over 2 to the negative 7. Okay, 1 over 2 to the negative 7 becomes 2 to the 7th over 1. Well, we don't need the 1 on the bottom, right? Because 2 to the 7th over 1 is the same as 2 to the 7th. Remember that when it's over 1, it's divided by 1. 2 to the 7th divided by 1 is 2 to the 7th. So 2 to the 7th. Okay, now if you've got a fraction, it works exactly the same. So if we have 5 to the 7th, or 5 over 7, sorry, 5 over 7 to the negative 2, it becomes 7 over 5 to the positive 2. And then if we have 2 over 5 to the negative 3, it becomes 5 over 2 to the positive 3. So notice that it's actually pretty simple. It's just the reciprocal. We just flip the fraction. Now remember, when you're typing fractions, you do parenthesis, then the fraction button, then the 5 in the numerator, then the 7 in the denominator. Oh, nope. What did I forget to do, everybody? 7 in the numerator, 5 in the denominator, because remember, you have to reciprocal. Click your cursor outside the parenthesis, click your exponent button, and it's positive 2 now, because you did the reciprocal. So now your exponent is positive. Okay, parentheses, fraction, 2, no, not 2, 5, because you have to flip it. 2 in the denominator, put your cursor on the outside, click your exponent button, and it's positive 3 now. And submit. Okay, number 2. So last week we learned about the product rule. So now we're going to do the product rule, but with negative exponents. So if we take a look at our example, we have 5 to the negative 4 times 5 to the 3rd. Well, we learned last week that that equals 5 to the negative 4 plus 3. So then that ends up being 5 to the negative 1, which becomes 1 over 5 to the 1st. Now, you may be wondering, why does that work? Well, 5 to the negative 4 is 1 over 5 times 5 times 5 times 5. And then 5 to the 3rd is 5 times 5 times 5. Now, when you multiply those, you end up with 5 times 5 times 5 over 5 times 5 times 5 times 5. And then you reduce, remember, that reduces to 1, that reduces to 1, that reduces to 1. So in the numerator, all we have is a 1. And then in the denominator, we have 5 times 1 times 1 times 1. 5 times 1 is 5. So we have 5 to the 1st power. Okay? So now let's see what we're going to do here. So number 1, this is where we're going to start working in our work area. So number 1, we have 5 to the negative 3 times 5 to the negative 4. So 5 to the negative 3 times 5 to the negative 4. Okay, we know that that equals 5 to the negative 3 plus negative 4. So we know that that is 5 to the negative 7. But then we learned that if it's a negative exponent, we have to do the reciprocal. So it's 1 over 5 to the 7th. 1 over 5 to the 7th. Okay, now we're on number 2. So we have 5.6 to the 4th times 5.6 to the negative 6. And that equals 5.6 to the 4 plus negative 6, which equals 5.6 to the, okay, 4 plus negative 6. I have 4 positives and 6 negatives. If I have both positives and negatives, I have to subtract. 6 minus 4 is 2. And then the 6 was negative, and that's the bigger number, so it's got to be negative. So then I have to put it over 1, and then I have to do the reciprocal. So I only do the reciprocal if my exponent is negative. And it ends up being 1 over 5.6 to the second. 1 over 5.6 to the second. Okay, now the third one, number 3. We have 3/5 to the negative 7 times 3/5 to the negative 3, which equals 3/5 to the negative 7 plus negative 3, which equals 3/5 to the negative 10. Okay, but I've got a negative exponent. So the only time that we do the reciprocal is when the exponent is negative. So I have to flip it, and it becomes 5/3 to the 10th. So 5/3 to the 10th. Okay, make sure you get all the work in before you submit the question. So this one was 1 over 5 to the first. This one was 1 over 5.6 to the second. And this one was parenthesis fraction 5 over 3 to the 10th. Oh, it didn't like my 1 over, oh, that wasn't 1, was it? My bad. It was 5 to the 7th. There we go. I fixed it. Number 3. Okay, now we're going to do the exact same thing, but we're going to do it with the quotient rule. Okay? So this is the quotient rule with negative exponents. So our example over here on the left, we have 7 to the 6th over 7 to the negative 2. Now, we learned last week that with the quotient rule, we subtract our exponents. So it becomes 7 to the 6 minus negative 2, which is 7 to the 8th. Now, notice this is just 7 to the 8th. No negative exponent. We didn't have to do anything. Okay, now over on the right side is the y. Why does that work? Okay, well, 7 to the 6th is 7 times 7 times 7 times 7 times 7 times 7. Okay? 7 to the negative 2, remember, is 1 over 7 times 7. So then we end up with 7 times 7 times 7 times 7 times 7 times 7 divided by 1 over 7 times 7. Well, when we divide fractions, we flip the second one and multiply. So it becomes 7 times 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 7, which is 7 to the 8th power. Okay, now let's start doing these. So again, you have to show the work. So we have 2 to the negative 8 over 2 to the 5. Okay, so 2 to the negative 8 over 2 to the 5th is going to be 2 to the negative 8 minus 5. Remember the rule. Quotient rule, you subtract your exponents. Okay, I make it plus negative. So it becomes 2 to the negative 8 plus negative 5. If I have 8 negatives and then 5 more negatives. I add them and I have 13 negatives. So, I've got a negative exponent. So I have to put a 1 on the bottom and then I have to reciprocal. So 1 over 2 to the 13th. 1 over 2 to the 13th. Okay, number 2. Number 2, we have 4 to the negative 5 over 4 to the negative 8, which equals 4 to the negative 5 minus negative 8. Okay, now remember minus negative becomes plus positive. So I have negative 5 plus 8. I have 5 negatives and 8 positives. If I have both positives and negatives, I subtract. So I have 3. 8 minus 5 is 3. The 8 is the bigger number and it's positive. So there's my answer. Notice I don't need to do the reciprocal because I got a positive exponent. 4 to the third. Number 3. 3 to the 4th over 3 to the 8th equals 3 to the 4 minus 8, which equals 3 to the, plus negative. So I have 4 positives plus 8 negatives. If I have both positives and negatives, I have to subtract. 8 minus 4 is 4. The 8 is the bigger number and it's negative, so the 4 is negative. I've got a negative exponent, so now I know I have to do the reciprocal. So 1 over 3 to the 4th. Okay, make sure that you get all of the notes written in before you submit. So this one was 1 over 2 to the 13th. And then this one was 4 to the 3rd. And then this one was 1 over 3 to the 4th. Number 4. Okay, number 4 is the product rule. So 10 to the negative 5 times 10 to the negative 5 equals 10 to the negative 5 plus negative 5 equals 10 to the z. Now remember, negative 5 plus negative 5 has to equal z. Negative 5 plus negative 5 equals z. Okay, 5 negatives plus 5 negatives is 10 negatives. So negative 10 equals z. Number 2, 10 to the y times 10 squared equals 10 to the y plus 2 equals 10 to the 4th. Remember, we know that y plus 2 has to equal 4. Okay, what's happening to the y? It's being added by 2, so we have to subtract 2. So y, 2 minus 2 is 0, equals 4 minus 2, which is 2. Okay, number 3. 10 to the 12th times 10 to the p equals 10 to the 12 plus p equals 10 to the 17. So 12 plus p has to equal 17. Okay, what's happening to the p? It's being added by 12, so we have to minus 12. 12 minus 12 is 0. P equals 17 minus 12 is 5. Okay, make sure all the work is written in before you submit. So it was negative 10, 2, and 5. And the last one. So the last one is using the quotient property. And I'm not sure why. Notice on the denominator of this one, it says 0, 9. It should just be 9. I don't know why they did that. So 8 to the negative 5 over 8 to the negative 9 equals 8 to the negative 5 minus 9, which equals 8 to the r. So remember, we change it to plus negative. Now remember that negative 5 plus negative 9 has to equal r. Negative 5 plus negative 9 equals r. Well, 5 negatives plus 9 more negatives is 14 negatives. So r is negative 14. Okay, number 2. 8 to the x over 8 to the negative 3 equals 8 to the x minus negative 3 equals 8 to the negative 9. Okay, now minus negative changes to plus positive, so we know that x plus 3 has to equal negative 9. Okay, what is happening to the x? Well, it's being added by 3, so we have to minus 3. So we have x, 3 minus 3 is 0, negative 9 plus negative 3, because we change it to plus negative. So 3 negatives plus 9 more negatives is 12 negatives. So the x is negative 12. Number 3. We have 8 to the third over 8 to the m equals 8 to the 3 minus m equals 8 to the 14th. Okay, remember that 3 minus m has to equal 14. Okay, this one's a little more complicated. What's happening to the m? There's an invisible 1 right there, right? So it's being multiplied by negative 1 and added by 3. Remember that you always have to undo the addition first. So it's being multiplied by negative 1 and then added by 3. So we have to minus 3, because we always have to undo the addition first. 3 minus 3 is 0, so we have negative 1m equals 14 minus 3, which is 11. So now the m is being multiplied by negative 1, so we have to do the inverse of multiply, which is divide by negative 1. Negative 1m divided by negative 1 is m, and 11 divided by negative 1 is negative 11. And there we have it. Negative 14, negative 12, negative 11. Whoa. Negative 14, negative 12, negative 11. Now, make sure that you have all of the, not negative 14. Did I say negative 14? Negative 5 plus 9 is 4, not negative 14. Okay, I have to go back and make sure I did that right. So 8 to the negative 5 over 8 to the negative 9 equals 8 to the negative 5 minus negative 9, which equals 8 to the r. So I change it to plus negative, or plus positive. So r has to equal negative 5 plus 9. So r equals 4. I don't know how I did that, you guys. I'm very sorry about that. So I messed up because I didn't do minus negative. So now you've got it right. So r equals 4. Okay. So now you are ready. Make sure you have all the work in and you are ready to go start homework. Homework 4C. Have an awesome day, and I will see you in class. Bye-bye.